So I talked about the real chemistry, and now we're going to look at how we see the real chemistry of what's going on in solution. And this comes about when we talk about the ionic and the net ionic equations. Now, up till now, we showed the compounds, and those were molecular equations, and those are the kinds of equations you worked with in your introductory chemistry classes. Now we're going to talk about the ionic equations, where we have ions floating around in solution. Ions have charges, so when we look at these, it's important that we have the same charge on the reactant side and the product side. So now we add something to our balancing equations to always check that the charge is balanced. When we balance an equation, the charge does not have to be zero, but it has to be the same on both sides. Then we look at the ionic equation, and we see if there's anything in there that's floating around in the beaker when we start and when we finish. And if there is, we cross it out because we call that a spectator ion. And then we look at the real chemistry, which is left, which is the net ionic equation. So, ionic equations show what actually exists in solution. I think of this as what's in my beaker. What's in my beaker is this. If we have soluble strong electrolytes, so that means if we have an ionic compound that dissolves in water, then that's a soluble strong electrolyte. Strong acids, strong bases fit in this category. So, since they are dissolved and they are broken apart into the ions, we write them as ions. We don't write them as a compound. Insoluble strong electrolytes, even though they're still strong electrolytes, and what does dissolve breaks apart into the ions, because it's not soluble, it's sitting in a lump on the bottom of the beaker, we write it as a solid in our equation, because that's what we would see with our molecule seeing I and our real I. So let's look at some examples of this that show the ionic and the net ionic equations. And again, net ionic shows the real chemistry. So here's an example of an acid-base equation where we make a weak electrolyte. We have sodium hydroxide and hydrochloric acid. They trade partners, and we make sodium chloride, which is aqueous, and water, which is a weak electrolyte, and it's a liquid. Weak electrolytes are in their molecular form. If I look in my beaker at this point in time, with my molecule C and I, which I wish I had, we have sodium ions, chloride ions, and water molecules in there. There's no sodium chloride in there. It all broke apart. So now, if I look at my ionic equation, I write down what's in my beaker. Well, my sodium hydroxide breaks apart and makes sodium ions and hydroxide ions in the beaker. My HCl gives us hydrogen ions and chloride ions, because hydrochloric acid is a strong acid. Strong acids get broken apart. If this were a weak acid, we would leave it in the molecular form. Now over here I have sodium chloride, which gives me sodium ions and chloride ions. Water is a weak electrolyte, so I leave it in the molecular form. So I change my molecular equation, the compounds, into the ionic equation, what's in my beaker. Now I look at what's in my beaker, and I see if there's anything that's not doing any chemistry. I have sodium ions to start and sodium ions to end. So the sodium ions cancel. They didn't do any real chemistry. They are spectator ions. I have a hydroxide here, but no hydroxide over here. It's hooked in water. Hydrogen here, no loose hydrogen. And I have chloride on the reactant side and the product side, so the chloride's not doing any real chemistry. So when I look at what's left, I have hydroxide and hydrogen reacting to make water, and that gives us the net ionic equation. So I use the analogy of trading partners at the dance. If you think about that, sodium brought hydroxide to the dance. Hydrogen brought chloride to the dance. Then, hydrogen and hydroxide hooked up and left together. And that left sodium and chloride still hanging out on the dance floor alone, right? They got to find their own ride home. So you can think of it as trading partners, and then who's ever left that doesn't get out of solution. And the real chemistry is the ions that are required to remove ions from solution. So now what I want you to do is do these same equations we worked on before, but now you're going to write balanced molecular, ionic, and net ionic equations. These are the same 4 equations from the previous page. And we're going to have some groups do each of these on a board. Cameron, let's have your group do this first one. Sierra, are you in Cameron's group? Michael, are you in a group with Sierra or Cameron? Kristen? Olivia? So all the groups get together and do all 4 of these, and then you put your assigned one on a board and put it up on the front. So go ahead and do these with your groups.